Okay, so let's start with another question, that is scramble string. So in this question, we have a scramble string S to get a string T. Like we have to scramble the string S and we have to get string T using this following algorithm, and let's read it out. So if the length of the string is 1, then we need to stop, and else if the length of string is greater than 1, then we have to do these steps. First is we have to split the string into two non-empty substrings at a random index. Like if the string is s and we divide it into x and y, where s is equals to x and y, so we can randomly decide to swap two substrings or keep them in the same order. In this step, s may become s is equals to x plus y or s is equals to y plus x. Apply step 1 recursively on each two substring. That what does that mean? That in x, now x becomes the new s, and then x is also divided into two non-empty substrings, and then we can have an option to swap it or keep it same. Okay, and we are given, okay, it has been there that s and t are the two string. Here it is like we are given s1 and s2 that are of same length, and we have to return true if s2 can be scrambled string of 1, otherwise we have to return. So let's understand it using the example. We will understand this particular question more clearly. So let's say s1 is equals to grade. To understand it, let's see this image. So we are having S1 is equals to grade and S2 is equals to RG80. So we have to find that if S1 is a scrambled string of RG80 or not. So what we are given into the question, that we can divide our grade, like it is grade, and we have to we can divide grade into such like we can have a partition, and these two can be swapped with each other. Hmm? Like it can be great as well as REATG, hmm? As well as if we partition it from the second point, it can be GREAT, that is the original one, or it can be EATGR. If we swap it, we have both the options, GREAT and ATGRE, right? Then GREAT and TGREA. These are the two options. These are the, like, this is how we need to partition each and every thing. Now, for this particular GR, into this also perform we can perform the same thing, like in this part also and in this part as well. In both the part, we have to recursively perform the same thing. Like into GR, we can have this, like GR can be partitioned into G and R. So after swapping, what it will be? R and G. Okay. So here comes RG and EAT. Right. So we have RGEAT. So see, this is what our S2 is. There is a match. So this will be a like it will return true, right? And this will be in this case also the same thing will be happening. Like we will partition G and REAT. So it can be great as we can keep it as it is, or we can swap it. So if we swap it, so it will be REAT and then G. Then again we will subdivide it into REAT into, let's say, firstly we divide it from REAT and then REAT, REAT, and we can subdivide into REA and then T. Fine. So for every part, we can recursively solve this. We will recursively solve this. So I hope the question is clear to you all that we are given an S and we have to divide it such that it becomes X and it becomes Y. It becomes X and it becomes Y, and we have an option that we can swap them or we cannot swap. Like we will keep it same. So how to solve this particular question? Any idea that comes to your mind? See, okay. So we have an option like let's clearly see this one case. So we are having G R and then E A T, right? G R and E A T. Now we can perform this particular function and we will check that if after uh, scrambling it, we can have like we will do the same thing into this also. So let's say we S1 is equals to this and S2 equal to RG E A T, and at the first iteration we have divided it into this part. So we can see that this is the matching. Now for this, when like we have to match this with this and this one with this, right? What we are doing, we are finding that if these two are scrambled of each other and these two are scrambled of each other. So yeah, it is GR is scrambling of RG and EAT is scramble of EAT. Or we can do one thing more that let's say we have GR EAT and we have RG EAT. So what we can do, we will divide it such that we will match these one, we will match these that if this one is scrambled of this one or this one has the same scrambling as this one. Did you get my point? That firstly we will match these two with these two. We will make a partition here and we'll match this with this. Or what we can do, like I can tell you here in this string, if we say GREAT and another we have uh, something like ATGRE, right? If this is the condition, so what we will do, we will divide it from here. We will compare these two and these two, and this is also scrambled, so it will also give true answer, right? So this is what we need to do. I hope the question is clear. I will revise it once again. So we are given S1 and S2, and we have to partition it in such a way that one part is called X and one part is called Y, and this X and Y can be swapped or cannot be swapped. Like you have an option that you can swap it, or you have a choice. If you don't want, you don't have to swap it. And then you have to uh, find that if the S1 is a scrambled string of S2 or not. And you can repeatedly do it until like you have divided into non-empty strings. And for this, what we can do that firstly we will partition both the strings into two types. One is both the sides will be having same number. Like let's say it has x number of characters, and s2 will be also having x number of characters. And then we will compare the if they can be scrambled to one another, because if they are not equal, so they cannot be scrambled now. So we will take a string of length x and another of length y. Hmm? And then we will check it with each other. Another thing that we can try is firstly we will take here of size x and this is of size y, right? And in this string we will take firstly the size of y and then of x, and then we will compare, or we will see if they are scrambled string of each other. The x1, the string having length x with this one, and this with this one. So this is how we have to uh, do this question, right? So let's start our coding part. Let's clear our screen, and then let's start. So I hope it is visible to all of you, because my last time the code was not actually visible to everyone. So let's have a look on this. So firstly, let's make a new function. Okay, let's not. Fine. Let's do it by this only. So we have to see that is RAM. So first thing that comes to our mind, there were two things now. Uh, there were two things that firstly we will partition it with some number and we will compare it. But before that, what will be our like what will be our base condition? When both of the strings are equal, then we will simply terminate it and we will return true, right? So firstly let's write it that if s1 equal to s2, then what we need to return? We have to return true. The second thing that we must keep in mind is this, that if the length of string is 1, then we need to stop. What? And if s1 dot size is less than equal to 1, then we need to return false. We are not comparing for s2, because in most of the cases we are taking s1 and s2 as equal length. Okay, now let's, because see, if we will in this condition, what the question is, okay, if we will do this again and again, the complexity will be increasing more and more. So what we'll do, whenever something like this will occur, let's say that if E80 occurs here, and E80 will at some time occur in this position. Are you understanding what I'm saying? That this E80, this particular part will be happening when we will we will doing like R and then E80. R is separate and E80 is separate, and let's say G is one another. Now E80 will again, this thing will occur again. So we need to store it as well. So let us store whatever, like if E80 is there, E space 80. So we should have some stored value and we will take the information from the same. So let's continue. So let's take an unordered map, and we are taking key as a string, and we will store that if it is present or not. We can take it as bool, or I would prefer it would be bool only. Let's take it bool only. Fine. Okay. So we need to find that the thing we are scrambling. So if they are like already present or not. So if ump dot find, so what will be the key? Key will be the same, like if GREAT is there, so it will be like how we have defined it here. How we have defined it as G space REAT. So here also we will keep our key in such a manner that we won't lose any like anything. If E80 is there, so we won't lose E, neither E nor 80. So let's firstly make one string, and this string is our basically key, and this is equal to our S1 plus S2. Not plus, let's say space S2. Right? So this is the key, and we will firstly find that if key is present. If key is present, so if dot find is not equal to ump dot end, this is how we used to find our any key in our map. So we will simply return ump of key. Fine. That if we do not have like wait a second. If the key is present in the UMP, then we will simply return UMP. We need not to calculate it again. But if not, then what we need to do is we will iterate from the start, not from zero, because we don't have to take an empty string, right? From 0 to n, let's first define our n. So int n equals s1 dot size, fine. So n I plus plus. So we have to check two conditions. Firstly, if the same, like if our what I need to do, let's first make it. Okay. So we have, let's say, which one we were discussing at that time in this question, GR and EAT separate. So let's say we have GR and EAT, and for S2 we have RG and then EAT. Hmm. So we are storing it as GREAT space RGAT, and then we will check that if scramble if scramble of our this one s1 0 to let's say I. So what will be s1 dot sub st sub str of 0, and we have to take length as I, and s2 dot sub str of after I everything. Okay, if this is scrambled, and again we have to check if this one is scrambled, s1 0 to 1 and s2 also 0 to I. Okay, and here after I everything we have to check in s1 and s2. If this is true, then we have to return true. Hmm? And else what else we need to see? Firstly, we have to check this with this, that if these two are scramble or these two are scramble or not. And again we need to find that we will partition it from here. Now we'll check that if these two are scrambled of each other and these two are scrambled of these, this whole is scramble of this. Okay, so what we'll do, uh, another condition will be is scramble of s1. S1 we have to take, let's say we are taking 0 to I. So S2 we will take S2 we will take after I, so n minus I. After n minus 1, whatever is remaining, that we will check. And another will be, we will starting from S1 will take everything like GRE and EAT. This will also get matched now. So G wait 0 to I, and this got matched, and this will be from I. We have to take till 0 to n minus 1. And if it is true, then we will return true. And if none of these happens, and if none of these happens, we will simply return false. Hmm. And not to forget that we have to store it as well. Okay, so ump of key equals, and ump of key equals. This also we have to store, ump of key. Now let's run the code. I hope it will work fine. It is. Now let's test for example test case. It is running fine. Let's submit it. So this is our correct answer, and I hope it is understandable to all of you. Thank you, and have a nice day.